Welcome to the data science seminar. My name is Meelis Kull. I'm here professor of AI at the Institute of Computer Science, University of Tartu. I welcome you all here at the 46th data science seminar. Yes, it's a very long tradition. It started in 2016, autumn, and the first data science seminar was about machine learning. So we are here today on a topic that is not too far from it, Agentic AI, how to organize work with artificial colleagues, who does what. So the event has a long tradition, as I said, and it's an event that brings together universities, companies, public sector, and everyone who's interested in hearing about the timely topics of data science. And Agentic AI, definitely timely it is. So the agenda that we have for today is here. We will work in 2 sessions. So the first session, I'll first give a brief overview for those of you who I'm sure know about generative AI, but are maybe wondering what makes Agentic AI different. And then we'll have amazing speakers. Very happy to welcome the 2 guests from companies, Kristjan, Korjus, and Vieira. Kristjan will be presenting in the first part, and Stenver in the second. So make sure to be present at both. We'll be recording this event, everything except the beginning of the second part, where Stenver will do some live things, which you can't miss, because then you wouldn't be able to see that from the recording. And then I'm very happy for our speakers, Armando and Marilin, from our own institute here, University of Tartu Institute of Computer Science. And I'll tell you soon about what you'll hear from them. And then after the break, after Stenver's talk, there would be a panel discussion, which brings together all the speakers for diving into things that are on our minds, in addition to this main talks, and hopefully you'll have questions ready for them, and we'll end up with networking. So, but as I promised, we'll start with an introduction where I will tell you about what Agentic AI is. Before that, I would also like to acknowledge our funders, Estonian Center of Excellence in AI, and STUCK for helping to make this event happen. So, Agentic AI and humans and AI, who is doing what? What tasks are for whom? So I'm sure nearly all of us here have worked together with AI in one way or another. But this is mostly with generative AI, I think. So generative AI has come to our desks, and it reads materials, it writes, generates text, images, and beyond. Produces basically, some kind of report or, chat output. Now, what makes Agentic AI different than that? So, Agentic AI acts and gets things done. Not only just producing a report, responding to your queries with textual output, but actually runs a bigger show. Could be all from browsing the web, running different kinds of tools on the computer, why not making phone calls, running the business, and then also does the same as generative AI, which is just producing all the textual outputs and so on. So Agentic AI is really something that brings AI to being a digital co-worker of ours. And you can also think of generative AI as the brain, with amazing capabilities, but it's limited unless there are ways for this brain to directly connect to information sources and also to make difference in the world by acting, doing something in the world. And also maybe having a memory that persists across many longer time periods, not just the same discussion thread as we are used to having in generative AI. So maybe just to make sure we are on the same page with some of the terminology today. And I'll just kind of come up with my own definitions, but you can later disagree with me. But for now, agent is basically AI system or a part of it that uses some kind of tools to pursue some kind of goals. And typically it's powered by LLM or multiple of them. Well, maybe if I say agents, then it's multiple. Typically, agent probably means a single LLM then. Tools, these are pieces of software, but they are wrapped into such a form that these AI agents can easily call them through APIs or some other means, some kind of interfaces. And then there is specification that is something that really determines what the agents are doing, like some kind of textual description of goals, rules, the tools that are being used, the skills that the agent masters, and then maybe some success criteria. And then skills, I already mentioned now, are, well, as the name says, some kind of capabilities of the agents. But technically, in this agentic AI, they are typically just textual descriptions of how to achieve some kind of goals with the given tools. So skill can be a text file and some additional information, some code perhaps. And another one is guardrails. So we want to make sure that there is some safety mechanism in place that agentic AI wouldn't violate our rules. So there are some checks on inputs and actions and outputs perhaps. But how does it work internally? There is this brain, there are tools, skills. How is it really built to work? And a lot of it is just about preparing a set of text files. And there are standards then that kind of where developers have agreed how to write that kind of text files, what name to give to the files and so on. And one very common file is agents.md. So now that you know it, you can kind of, you're pro in agentic AI, you can say, I know, agents.md. So nothing else than just a text file that specifies how an agent should act. Kind of a README file, providing the context and instructions for an agent. You can find more information about this from that link. And then there are skills. As I said, textual descriptions, and they are often organized in a file system somehow. A folder having the kind of key file is skill.md, saying what kind of skill it is and kind of the essentials. And then there are maybe some additional materials like scripts, how to use that skill. But this is kind of from the abstract sense. Let's get concrete. Let's take a concrete example. And suppose we want to have an agent that is taking a text and summarizes it. I mean, this is something that we're used to doing with generative AI, so it's not hard, but let's kind of take an agentic view on this. And so we want to create these concise summaries, and we want to somehow use agentic AI for it. And the idea is that we have this task, and then LLM agent has some skills that it applies. Skills define kind of what kind of tools are available there, and then how to get to the result. But what is it in this particular case? So suppose there is an example tool, count words. So maybe we want to make sure that the summary is not too long, and so we want to be able to count words. And so, as we know, LLMs hallucinate a lot and can come up with, they are not very good at counting. Yeah. So maybe we want to make sure that there is a code, like some kind of program written to actually do the counting properly. And the skill could be how to summarize texts into 30 words. And it's kind of simple. You just draft a short summary, count the words. If it's too long, then make it even shorter. Kind of iterate until you have it short enough. I mean, nothing complicated. But for an LLM, by itself, it might be complicated. I mean, it might produce longer summaries, unless it counts. So with an agentic skill, it can kind of know what it should do and achieve the result. And then maybe we have this agents.md markdown file, which then says, like, this is the goal, this is a tool that we have, this is the skill that we have, and now we want to make sure that final answer must be under 30 words, and eventually you only need to produce the final output. And these are just text files, exactly as I've described. The skill is a text file, agents.md is a text file, tool in principle can be, but yeah, well, there needs to be some kind of code also behind, so that it can implement this overall result. So this is kind of the framework. So there are some kind of files that then the agent operates with, and how does it then eventually get into use? So we want to say this is a text that we want to summarize. Well, in this case, because the slide is limited, it's actually already shorter than 30 words, which makes it even easier. So what now AI needs to do comes in, basically in an LLM, checks like, oh, I have this skill, summarized to 30 words. Okay, I better use it because it's what is needed. So now I can kind of go into that skill, read, oh, I have this kind of a tool. I should call that tool, and then it knows, runs this tool, gets a result. And for this, it's not only LLM, but it's the software around it. Software knows that when LLM says, I want to call this tool, then the software takes care of it, actually runs the tool, gives the result back. So, because LLM is just a brain, right? And everything else around it, we need to wire when we are building an agentic framework. Of course, once the framework is there, as a user, we don't need to know about it. For the user, it's just about saying, I want to summarize, and everything happens miraculously. But yeah, practically, there is this LLM underneath and this framework around. The tool result is 13, which is wrong for this sentence because the slide was generated by AI and it hallucinated. Sorry. So I didn't run it agentic. I did run it agentic because when ChatGPT needs to produce PowerPoint slides, then it needs to also kind of have a skill to do that. And a tool to use to be able to do that. And yeah, behind the scenes, basically, agents.md gets read, selecting skill, calling the tool, returning final results. But there likely is going to be a loop, agentic loop, that runs many times to be able to achieve the task. In this case, it was just too easy and all ran through with the first attempt. So LLM is core. Framework is around it, tells how this works. And if agent is nothing magical, agent is basically just its files. A set of files, and then LLM operates with those files and is able to run the tasks. So what can be done with it? Well, let's say I want to plan a family holiday trip, and I say, okay, I want it, let's say Finland, second week of July, and agentic AI system runs, knows already, maybe it has access to my files, knows how many members in family, what I've done before, and figures it all out automatically. Totally doable with today's tools. Maybe I want to make sure it asks for permissions before making the bookings. Maybe it's smart to do. Maybe I want to spend not more than 10 euros for the planning. I mean, you could run crazy with infinite amounts of euros spent on just the planning. We don't want to do that. So there are risks. We don't want expensive mistakes. We don't want leaking credit card information and so on. So we need to be careful. Plan could also be resulting bad, particularly if the LLM is not very good. But yeah, it's totally doable with today's tools. Where is the current frontier? There are leaderboards that are on specific real-world tasks with a kind of economic value, trying to estimate which model. So compare one model against another with ELO score, say, be able to calculate which methods are better. And there are open source agents and agentic systems, and there are commercial ones. Open source, one of the key tools or agentic systems is OpenClaw, and because of that, the lobsters have suddenly become very kind of almost like sign of an agentic system is a lobster. So that's why also the lobster being in the events banners. So and then commercial coding systems. And main trend, increasing autonomy. Key risks, well, security, privacy, just wrong answers or bad outcomes, bias, and possibly huge costs. So AI agents are ready for digital work, no problem at all. It's just the question is, are we ready for all of this? With that, this is the introduction, so thank you. And we are ready to ask the question, how to organize work with artificial colleagues. And with that, I would like to welcome our first real speaker. Not that I am AI, but still. Kristjan Korjus. He's okay. He's from Pactum AI. And he's a co-founder and head of research. Research. What was the title? I hoped it was chief scientist. Yeah. Well, almost. Almost. But also he has a PhD from our institute a while ago, working on reinforcement learning and machine learning, and but you will tell more. And welcome.
Thank you. I'll give a brief intro about myself and then about Pactum AI, which is deploying AI agents, and then about how Pactum works internally with AI agents. And then we will reflect a bit about all the AIs everywhere. I studied mathematics in University of Manchester, and then I came to here, to University of Tartu, doing a PhD in computer science. I did many things while doing a PhD. It's a great thing to do. If you're a student, I recommend. We wrote a book, Bedside Reading about Mathematics, which was popular, but more importantly, what defined the career and why I'm talking here about AI was a random project where we replicated a research paper, and the paper was creating an agent that was learning to play arbitrary computer games. And I was leading the team that replicated this research paper. Paper is a couple of pages. As an open source project. And this small company that created or wrote the paper is called DeepMind. At that point, Google acquired them for $500 million, and we became experts of AI agents playing software games. And that defined the career in AI for me. I did many things in many countries, but one thing I did longer was building self-driving delivery robots in Starship Technologies, which is another type of agent that has autonomy and authority to do things on its own and drive along. I was there for 4 years, from being an AI engineer and team lead and department lead. And then I founded a company called Pactum AI, which is doing AI agents for large enterprises to help them with procurement tasks. So this agentic stuff in different forms has been there all the time. But something started changing with these large language models. This is my favorite graph and favorite website, metro.org. That's one of the few ones I'm visiting more often out of the research organizations. And they got famous because they invented the way how you measure the progress of AI development. On x-axis, you see the time, it's years from 2020 to 2026. And on y-axis, you see different tasks by the length of how long does it take for a human to complete them. And it is going up exponentially then. It's a logarithmic graph, meaning that initially the LLMs, when they came out, GPT-2 and then 3 and 3.5, they were able to answer simple questions what would have taken maybe a human a couple of seconds also in Google. But then they got better and better, that they were able to solve more complex tasks, look around in the internet, and now actually do programming and sometimes do things that would take humans 10 hours to complete. This particular graph is for software engineering related tasks, and with an assumption that they are correct in 50% of times. But I mean, they have a huge amount of data in different ways how you can look at it. But what it means that if AI can do tasks that are measured in hours, it means that it is now becoming useful in actual enterprise or in commercial setting of doing things, what needs to be done in a company. And it has created a revolution in very many ways, and that's why we have this setting in here, and that's why we are talking about it. This is an example of how we think about it, of what has happened in startup world and in software development in commercial world. That there are like 4 stages or phases of software evolution. The first one is the historical one, started in area of mainframes. SAP there, the second company on the first layer, is actually the largest software company in Europe. By revenue and by market valuation. This is the hardcore like system of records, and most software for most enterprises runs on them. And then over time there are like other, and this is only procurement example, then they have other like more modern softwares invented 20, 30 years ago that where they realized that it's time to go to web. And now there are hundreds and hundreds of startups that are built and promoted and getting funding, which is all in that case the latest ProcureTech layer of many different softwares. Some of you might know, I don't know, DocuSign, for example, helping just to put a signature on the papers. But there are lots of them. And now the 4th layer of this innovation on top of these layers, sometimes bypassing some layers, is the agentic revolution, where people are building software to actually not for humans, but for agents to do the work in the large enterprises. And of course, this example of procurement is the example of the company of Pactum AI. So 7 years ago, we founded Pactum to do procurement such that procurement will be run with Pactum AI agents. We can proudly say that we are a leading company in the world for providing these agents for the enterprise procurement. We have 160 employees, about 50% of them in Estonia, meaning 80 employees. And in the summer, we raised the Series C of $54 million. We have roughly 60 world-famous customers, only customers that are extremely large, including, for example, Walmart. And we are doing well. But like, what are we doing precisely? I'm not gonna show exactly the like UX and UI of these things, because it's also different for different agents. But we are providing agents into the approval flows or into the processes of large enterprises, providing specific agents that can do the work of humans. Sometimes alongside of humans, sometimes only helping them with the simple tasks and providing them information that is needed there, but that they are operating there and trying to fulfill tasks in procurement organizations that are buying stuff for the company. For example, they might help if someone needs to buy something. I don't know how it works in University of Tartu. Probably you tell someone that you need a laptop, and then someone helps you to buy this laptop. Then like we can answer questions to them. And then you might need to fill a request to somewhere. Then there is some system that helps you clean the data, understand what's going on there, helps to validate whether we have an official provider for it, going to the internet, checking whether there is someone else there, like giving out the purchase order, checking the invoicing end, like trying to automate these mundane tasks in an enterprise setting. But in here, and so we have been deploying AI agents for a long time with many people, and we are constantly thinking about it. But then also we have been very aggressive deploying the AI agents internally in Pactum. Like obviously every software engineer is using AI agents nowadays to do, or most of them in Pactum, everyone, but let's say in most companies, most of them in some ways. But what we did, we also have a team of people who was responsible for giving the AI agents to every employee of Pactum. So HR, sales, marketing, and so on. The particular agent that was on Meelis' slide as well is Claude Code that we are using, but it's quite easy to replace it with someone else. So everyone has Claude desktop with Claude Code in our company. And it's organized like this, that the Claude Code can access your computer. It has skills that we are maintaining centrally. So we are deploying these skills to people's computers, explaining the AI agent how it should do something if the person needs something. And then we have connected it to most of the systems that Pactum has. So companies usually have a lot of software that helps them to run the company. Maybe like the most famous one, of course, is like Gmail and Google Drive and Docs and Spreadsheet and Calendar, for example, what we are using, but also Slack. Then Jira for task management, for programming, Confluence for documentation, Salesforce for managing the sales, Gong that is transcribing and organizing all the calls that we are having, transcripts of all the calls, Looker for all the business analytics, and so on. So that means that and this Claude Code is accessing them with the user access rights. So it can only access the information that it could access anyway in real life as well, not central access rights. Meaning that every employee can do something like this, that, hey, Claude, please please, I'm interested in this pipeline about this product X. Please check from Salesforce all our leads for that product, and then please check all the previous recordings, sales call recordings, how are our salespeople selling this product. And then check whether they have the next meeting booked in the Google Calendar for these customers. And then this Google Cloud will go there, maybe might work, this is quite complex query, it might work there in an agentic way for maybe half an hour before it comes back with a report of what is going on. So this is what we have deployed, started deploying it from January, and now it's used by everyone. There are a couple of examples. First one is my brother, who's my CEO. Luckily not my boss. There's one layer in between. So I'm gonna take the example of the middle one for check an account executive. So they are using it to in that way that they say that check out all the features of this product and all the recordings that we have had with this customer and try to make a specific case for that. And go to the internet also and read about this customer and now merge these things together to a specific use case for business case for that customer because I'm selling that product. So people are feeling extremely empowered and are amazed by it. They love it. And it feels that absolutely everyone is more productive, works faster, better, and it's quite cool. And Pactum is even a tiny bit famous in Estonia for being progressive about it, so people sometimes even want to come to work in Pactum because of that. But now coming to the title of the talk. Recently we have started to think about it that if everyone is able to build slides, build demos, everyone is even able to build like new features almost to the product as a demo at least in some calls. Then like it's not the case that the company then definitely moves faster towards one direction. That if everyone becomes the builder, then you lose some type of alignment there. And like giving a couple of examples, like it feels that like one thing that becomes easier is to write new features and even new product lines. And the products are evolving and changing so rapidly that even people who are in Pactum, because Pactum is a large company already, 150 people, they are even not kind of keeping up to what is going on. And so you might be kind of telling something that, oh, this product is doing this, and then showing it, and actually it's already different. That this change is happening in some sense too fast, that there seems to be 3 different speeds. One is the engineers with AI delivering really fast and product engineering in general. Then there is internal Pactum that can at least use Cloud Code to kind of ask about all these features and things. And then there are customers who are trying to understand what Pactum is doing. And if these 3 speeds are too different, then it becomes like sometimes more difficult to sell the product. Maybe an example I like more is the personalized sales decks. So it seems to be a common knowledge that if you have some master sales deck, that if you're talking to someone, that you adjust it and you are making it for that case, and it should make it better, and it is making it better. But if everyone can do it extremely extensively, then of course it diverts even more from the same main message and from the main thing we are trying to achieve. And so it might be resonating very well, but then the next team who also did it independently is talking about something different about the same company we are selling to them. And then the marketing and brand is different and the website is different. And then you're in a situation where you're again, everyone talks about Pactum, about our products differently, meaning that this hyper-personalization there is actually not benefiting the situation. But what is even more interesting for me is that we are somehow losing the ability to learn. Because before it was like this, that we have a central sales tech and we were able to use it everywhere. And we were able to, for example, change it after 2 months. And then we were able to see from the metrics, is it going to better or worse? And what is not working there? But at the moment, we cannot, or this feedback loop is somehow stopped because, or broken because everyone is building on their own. They're building better ones. So I'm not trying to say that it's worse, but somehow the global alignment is not definitely there. There are more and more examples. And maybe they are too tech company focused. Architecture decision records, if you read about it in Google, it's like most important decision in a company recorded in a really short way, like half a page. Only most important decisions, they were important. Now there are so many of them, they are so long that I'm not reading them anymore. It just doesn't work like this. And it applies to every document, every Slack post, every review, everything that is there. It's more comprehensive, looks at it from more angles, is better locally. But I'm not sure whether it's better globally. And how do you, there are many ways how to think about it, and I had 20, 30 different theories from different fields of science of how to frame this phenomenon. But from the experience, some of us have experienced it when a startup, when a company grows a lot, 3x in a very short period of time, then there is a confusion and everyone is confused. So maybe it's temporary, maybe it's just our company became 3x larger because of the AI agents, and everyone is more productive and it will resolve itself. But I already mentioned it, the way how I think about it is that not every local improvement is necessarily global improvement if it's already enough people there. And maybe I'm going back to the extremely basic idea that maybe one way to think about it is 80-20, that 80% of the value comes from 20% of the output. But with AI, doing the rest of the 80% becomes so easy that now we are doing it, and therefore producing so much that we are reducing focus from the most important 20% that was needed to be there. Maybe going to the classics, at least in tech entrepreneurship world, that people think focus means saying yes to the thing you've got to focus on. But that's not what it means at all. It means saying no to the 100 other good ideas. Saying no to the good ideas is the most important. And this is becoming harder and harder as we have these guys who are working for us for free. So these were my ideas. In Pactum, we maybe reached, we are there further away than most other companies. If you find this exciting, you can consider coming to work for Pactum. And I will leave you with one other quote. So thank you.
Thank you very much, Kristjan. Time for questions. there is one. So please, microphones start to move along your way because we're recording. We want to make sure that you ask together with a microphone. Please.
So the question I was going to ask is, you work with Agentic AI, and you especially work with more sensitive parts, such as procurement cycles, where a hallucination or an error made by AI could lead to massive losses by the corporation. How do you account for that? How do you deal with the possibility of those errors?
Pactum started in procurement, but in negotiations. So we were doing negotiations representing the large enterprise with the suppliers. Of course, at that time, there were no LLMs either. But at the moment, it still is not the case that you can do free-form negotiation in this setting, as you mentioned. So it is still true. In that setting, when we are talking to the supplier in an autonomous way, then there are a lot of systems. There is a formal mathematical space with all the terms we are negotiating. We are using LLMs to generate text, and we are using LLMs to understand free text, but we are never allowing this situation where the free text influences the text we will be generating, in order to break the loop and not allow prompt injection, even if the prompt injection is not deliberate. So basically, there are a lot of systems around that make it possible to do these things, and in that case, they are not. You could say they are not as agentic, or you can say even that it's not that AI because of that. But I think it's not the correct way to think about it. Starship robot not using LLMs doesn't make it non-AI. It is still a robot that is self-driving, meaning that we are solving this bit by bit, keeping structure there, having safeguards in places where it's needed, asking help from the buyer. When it is safe to automate this part, then we are automating it. So it is like a hardcore software development for the last 7 years with 40 people in order to be able to do it at all in some niche places.
So we could say that some humans do evaluate the results at certain checkpoints.
Yes, in some cases. In some cases, it's our humans. In some cases, it's the buyers. In some cases, it's fine to do mistakes from time to time. Yes.
Just one more question. You said these negotiations, is it like on Alibaba or digital platforms like that? Like, where exactly are these quoting mechanism? Where exactly?
I mean, we have different type of agents and different cases. Let's take an example from what would be famous in Estonia, Rimi, for example. Rimi has maybe 50,000 suppliers. They're buying 100,000 items into thousands of stores, agreeing on prices, delivery terms, and so on. In total, roughly, I don't know, 100 million numbers are agreed every year. There is huge volume in making these decisions, how you decide to procure things into your company, in order for, in case of Rimi, to later sell it, but in some cases later to produce something from it or use it for indirect things. And there are many jobs associated with it. It was also in one slide, I'm not sure whether the slides are shared, that there are many checks and things that need to be done, and yes, sourcing is one of them.
So there was a second question. Was there some other? Third one here. Okay, no, second one here then. And please raise your hands higher so that I can see queuing up.
I have, thank you, Kristjan. I have a relatively simple question, unlike usually. So people are saying that AI price is going up is one. Of course, fear of missing out, lost opportunity. You kind of advocated against using AI too much, or that too many people use it too widely. But what I want to ask you, concrete fact number, what is the price of your Claude token bill monthly?
I'm so sorry. I don't know it by heart. I will find it out. Maybe for the panel session, I will reply it. To be precise, I did not advocate not using Claude Code. In Pactum, there is no plan to reduce the usage of Claude Code, to close it for anyone or anything like this. We are going all in with it. It doesn't mean that any technology you use that there aren't also negative effects to it around it. It is just a question of what you invent in order to be even better with it or be good with it. Like a couple of days ago, one analogy there was that when at one point when there was enough internet and the programming languages were a bit better than, let's say, C language was, that we went a bit higher level, there was more internet, people were more connected, then also these things started to happen, that too many features were built, there was chaos and so on, and then new methods were invented. For example, lean startup things with Scrum Masters and Scrum, like these boards and like all these things in order to organize the work somehow, design sprints to get the customer closer to it, that we wouldn't build too quickly to random places. Like I think we just need to think about what you do now, how do you handle it now if you are even more faster. Like if you cannot even finish your one sprint, everything will be done while you talk. Like then it becomes that then you need even more upgraded methods to handle this situation of how to do it. So I'm not advocating to use it less, and in Pactum we are advocating everyone to use it more. But the question is how to do it, and then there are many things that we are also testing and trialing. But most importantly, everyone must understand that if you write something, then it is you are responsible, and you cannot blame AI for mistakes, like Meelis just did before with the slide.
Thank you. It was very, very interesting. I was following up this previous question of you are balancing like development, implementation, and learning curve. And I was wondering, will the standardization be put into this position also? If in old days you need to have like common sense said that take a breath before you make decision. How to put that recommendation now into your picture, which says the speed will be better, and you don't have even within your own organization time to understand what you have.
So maybe extrapolating your example, then maybe you should take a day before you make a decision.
Thanks.
There was one last question somewhere there. I mean, I've seen more hands, but we need to leave the rest for the panel.
Thank you. I'm also at a company that has given most of its employees, including product managers, designers, cursor licenses, which means agentic AI workflows. And it is chaotic, I agree. Everyone is vibe coding their own front ends and basically reinventing the wheel every time. And now my question is, how do you prevent this kind of, let's say, token maxing and just using AI for AI's sake? And what's your strategy moving forward? How do you at one point try to balance how engineers are supposed to use AI to, the term is, what was it? Empower their workflows as opposed to product managers just vibe coding something in 2 hours and then asking engineers, hey, I did this in 2 hours, why can't you finish this in a week?
So first of all, how do I avoid token maxing? I don't think that this is a problem if the founder of the company says these things, that maybe you are building too much, then being proud of doing too much is definitely not something that you be proud of. And this comes with this culture of thinking about how do you work and how do you add value for people to who you are writing the software, so that this becomes more and more important, and long-term strategic thinking about the product direction becomes more and more important. Yes. So yeah, it doesn't seem to be a problem at the moment. And the second one also not. So I don't know. I'm unable to answer at the moment. Maybe the level of people must be very high, even higher the more they can leverage themselves.
Thank you very much.
Thank you.
So next, I'm very happy to welcome here Armando. Are you around? Yeah, you're coming. So your slides up there, not yet here, but okay. So this is coming with the slides. Yeah. So Armando da Silva Vieira is a lecturer of applied AI here at the Institute of Computer Science, and so he's using Agentic AI a lot. So I hope to hear more from you. So please.
Okay, thank you. Let me take some water here. So yeah, thank you for the introduction and invitation. It's really a pleasure to be here. I come from a very different culture from Estonian, but I'm learning how to adapt to how to keep the silence, because coming from Portugal are very noisy, very mix their hands. And anyhow, yeah, the topic of the conversation is about Agentic AI for science. I'm a scientist myself. I'm a physicist that turned into a data scientist and done many things in my life. But my passion is really science. I really care a lot about science. I think it's something that we should value more in our society. So science has went through a long journey since the early stages. If you start like in the 17th century, the revolution, scientific revolution, initially science was very empirical. So we went to the lab and tried to do amazing things like changing materials, adding stuff, trying to create gold out of nothing, and eventually succeed. But that was not very effective. It was very painful. It was still today is very painful, and it was. We don't have any guidance until we get the first mathematical realizations of science. This is the well-known Faraday equations. And what this brings to science is mathematization, is formalism, is the capability to expand between the concrete cases that we find out in the lab and expand to a much wider range of applications. In the case of Faraday equation, in the Maxwell equations, we will be able to unify electricity and magnetism, and at the same time, we were able to extrapolate that to other phenomena like radiation and light. Moving forward to the present day, we got to the AI stage where computers are first to become tools to run these equations and find incredible new solutions. Nowadays is even deeper entering into science, especially in biology, where you don't have these beautiful mathematical equations. Everything is really messy. There's a lot of data, genetic, you name it. And algorithms is making sense of all of this data. But I think we are, with Agentic AI in particular, we are in something even bigger than that. And by bigger, I mean we are at the point where these systems can become multipliers of human effort. By multipliers, I mean not replacing humans, but expanding and accelerating tremendously the speed of what we make research. If you have been attentive to Nature, you see that last week, I think it was last week, they published 3 papers. And all of them are about this agentic AI thing in science. How, with some concrete examples, most of them is from drug discovery, which is a very hot topic, about how agentic AI can really help and can really accelerate the discovery of new drugs to treat very complex diseases. So for me, the message I want to convey here is about the mindset, okay? I want you to leave this room and stop thinking AI as tools. Okay, this is over. AI is no longer a tool. AI is a very sophisticated assistant or partner that you have working with you. Okay, this is the important mindset that you want to carry on. It's going to help you and it's going to contradict you, is going to challenge you many times. If it's not challenge you because you're not pushing it hard enough. And the idea is to science become less of a pipeline and more like hybrid cognitive system, hybrid between humans and machines. I don't want you to become a cyborg, but I want you to take full advantage of these systems. So, as I said, AI is no longer merely a tool for science. It's not just a method for knowing the world, but a way for the world to generate new forms of knowing. So it's like metacognition. I like to use this analogy of percolation. Percolation is basically a system where we have different nodes, like a graph. And I like to use it because I see science, unfortunately, very much as a big ocean full of islands. And each individual is looking just his own island without seeing the whole universe around him. And I think this is unfortunate because it's often the case that the activity you are doing in your very, very tiny research field may be useful in the other fields that you never communicate with. So for this particular case, it's very useful to rely on this agentic AI. And I've been using quite a lot. I will show you some examples, some successful, other unsuccessful, but that's what it is. So one thing I want to make it clear is that I see many criticisms about generative AI and agentic AI. Oh, they're just interpolation, they cannot do discoveries, they are just memorizing what is in the internet. I think this is completely wrong, and it completely misses the point. I'm not saying they are genius, they're not genius, but what we do as scientists most of the time is just also replicating what is already there. I call it incremental science. Improving a little bit an experiment, finding something with less error, better simulations, making some perturbations about things you already know, is called incremental science. And these two published papers, so why science, agentic AI can also help and can also do that? They can. And of course, the real transformative science is rarer, and it happens very rare. But when it happens, it also doesn't come out of nothing. For instance, quantum mechanics is started from some abnormalities. And all of the data points already there for someone to connect them and do this percolation that I mentioned before. But these small improvements, I think AI is possible to do it. I'm not saying AI is going to win the Nobel Prize, but we should really leverage on this knowledge and these capabilities to connect the dots and connect this small improvement and make a huge improvement. So I'll keep some slides. I think I already passed this message that this mindset, seeing AI as a partner, someone who really help you find new breakthroughs. Just to summarize in this slide how I see AI, traditional AI from agentic AI. So in the world of, I'm sorry for the letters a bit small, in the traditional world of using AI, I think everybody already uses it. So it basically you write a prompt, and you come out with an answer, or sometimes with a wrong answer, but you come out with something. You get some hypothesis, you explore step by step. After that answer, you got another question, and so on and so forth. Eventually, it works, you reach to something, but this is a very time-consuming process. It's very painful, and it's not always the best way to do it. So Agentic AI has the potential to really put this process in steroids and make it in parallel. So instead of having just one system working for you, why not have a whole army of little bots that can do this optimization or this search for you automatically at scale? And that's pretty much what it is, Agentic AI. It's basically, instead of having just one assistant, you have an army of assistants that work for you, and eventually reach some conclusion. As it was mentioned already in the first talk, we need to build some guardrails, otherwise we get some naughty surprises, as I will see in a minute. But that's pretty much the idea. I like to use this analogy that I find inspiring. I see the agentic world as you are in mission to discover a new planet. Okay, so you want to know what's the habitants about, what is the atmosphere, the animals, whatever they can find in this new planet. You don't know nothing about it. So one way to explore it is the way we've done with the moon. We prepare a mission. We make a very engineer and optimized spaceship. We send the spaceship to the moon. We collect some samples. And then you're back in the Earth. You analyze the sample to see what's there. So this is pretty much the traditional way of exploring a known world. Another way to do it is, instead of controlling the whole process, you send a spaceship with your bot, with your agents, and you let them explore by themselves, okay? You let them have some freedom. Some of them will probably explore the earth, other the ocean, other see if there are some animals, communicate with the locals, if they are friendly or not friendly. I guess they should be friendly. I don't see why they should be not friendly with us. Maybe we are not the ones friendly with them. But yeah, anyhow, so the idea is that in this army, the B side of this is that you are not in control of the process. Okay? So the process pretty much unfolds on its own. So eventually hopefully they will coordinate the effort, but they may rebel against you. They may not want to communicate with you. That's possible. And in fact, they may start arguing with each other. And so we have like a whole society of its own. This is not completely science fiction. It happened to me a little bit, and I will show you in a minute. So this is the difference between traditional AI and agentic AI. So traditional AI, you have like your own assistant, very well behaved. You know, you have your system prompt. You know it should behave. You put the answer, get the question, get the answer. In the agentic world, the type of prompts you do, they are generally more open-ended, broader, and the results can be more unexpected. So they are multi-agent. They are specific for different tasks. They run continuously. They don't have a stop criteria. In the case of traditional AI, you have a question, you have an answer. In this world, you don't know when they will stop. Eventually, they will consume millions or billions of tokens, and you run out of budget to deal with that. So it's a very different perspective. I will skip some of these slides for the sake of time. Yeah, some examples, as I mentioned before, biology is a really rich field to explore agentic AI. The reason being because the search space is enormous, many, many molecules. It's estimated to be the order 10 to the 60, which is almost as big as the number of atoms in the universe. And most of these molecules are poisons to humans. Some they don't work in the target. So there's lots of things can go wrong. So this cycle, this virtuous cycle of iteration is quite important, and it's very difficult for a human to just look at a molecule to target a specific protein and see if it's going to work or not. So the process needs to run on itself. There are many companies working on it. This is an example from my own reality. So it's a case that I worked with. I was working with a framework called the RAF, Reflective Autocatalytic Food Set. It's something that is proposed to explain the origin of life in the 90s. I think it's a very promising framework. It's basically designed to analyze graphs, complex graphs. And I was wondering why this could be applied for genetic relatory networks. And I launched my agent. I decided one was to be literature review, another one I explained, which is what are RAFs, and I asked them to test some hypotheses for studying cancer. Okay, and they come out with a very interesting approach. In this case, it's for mammal cancer. Okay, for the breast cancer. I'm sorry. That is very aggressive type of cancer. And what they found out, I'm not going to treat the cancer, but what the end result of this experiment was interesting, was not for me obvious, the metrics they came with. So they proposed a few metrics that are mentioned here. I cannot read, so it's the impact, so it's a breach edge criticality, I cannot read the other one, the food set strength. So basically they measure, in this particular case, it is well known what are the important genes. That's not the relevant thing. The relevant thing is that other genes in the network, the regulatory network of the genome, that are super important in terms of establishing a RAF. What is a RAF? A RAF basically is a subnetwork in the graph where the genes relate each other and they stop to be responsive to the medium where they are located. So they live like they have a life of its own. Okay? And they propose some other genes that are not very well studied. And at this very moment, I'm in the collaboration with oncologists. And we're trying to see how good are these genes in terms of explaining the cancer. Another example, also positive example, was for reinforcement learning. So in this case, it was an experiment for to learn to teach a robot with 2 legs, to be pedal robot, how to walk. So the first 2 columns are for the first is a robot trying to learn. So the blue is the traditional autocritic model to learn how to walk. And the important piece is this third column here. In the third column, I introduce some perturbation. And this perturbation is winds and change the gravity. So my point is, can I make an algorithm to be curious? Because most of machine learning are not curious. I have to use this example. You put the children in a room with toys, and you put the robot, and what both of them are doing. The children is playing with the toys, is trying to make things out of it, or destroying the toys. The robot does nothing, unless he has a very explicit reward function what to do. He does have curiosity. Or if you put in front of a screen, the robot gets very happy because everything is predictable if the screen is blank, and the children get bored. So this curiosity problem is a very well-known problem, and I was able to create a very interesting implementation of it, and it's another successful example. I have another unsuccessful example, which this case was to create, as you know, these LLMs, they have several issues. One of the issues is energy consumption. They consume a lot of energy. So one way to solve this is using optical computers. Okay, optical computers are much energy efficient, but they have some issues in terms of implementation. They are not ready to be used. And I came across this architecture with the help of these agents. It seems to be very interesting architecture. The only problem it has is that it was trying to implement something that was not technically feasible. Okay, the properties of the system that were required, it could not be physically implemented. But the systems tried to do it again and again and again and again until eventually I stop it. So the lesson here is you have to know what you're doing. The system will never give up. It's trying to do better and better. Oh, let's change this parameter. Oh, let's try different architecture. And eventually it gets stuck. Okay, so you have to kill it. It will not be able to say, I failed. So they cannot say that. So we have just 50 seconds. I will skip to the final slides. There are a few frameworks you can play with this. Oh, I'm sorry. I have to go back. There are a few frameworks you can play with these agents. One of them is Science Claw. You can find on GitHub. But I want to go to the end slides. So, summary, science is a loop in terms of question, hypothesis, and testing. So I think Agentic AI can help a lot speeding up this loop. Of course, they want to produce lots of bad hypotheses, lots of hallucinations, but that's not the point. The point is that they are going to produce that at scale, and you as a scientist can really filter out the ones that are valid, the ones that are not valid. And you can have a much richer set of hypotheses to explore and to progress. So I'm very optimistic about the use of Agentic AI in science, and I'm happy to answer some of your questions. Thank you very much.
While you're preparing your questions, maybe you could show at least one of the slides that you skipped, because I had the advantage of kind of seeing it in advance, but like you had some key messages, like this one, yeah, the one in red, the next slide maybe.
This one?
Yeah. So I think this is very quotable. Good science is not confidence, good science is disciplined doubt. And I believe I saw more in your earlier version, but
I changed a little bit, yes.
Yeah. So I think the point that you're making, that kind of AI can help you explore so much more efficiently. So yeah, I think that's a great point. But questions?
Thank you, Armando. On one hand, we know that LLMs are essential for this agentic AI, as Meelis described it. On the other hand, we know that in biology, there are all these other methods for protein structures. You don't use LLMs, but rather AlphaFold, etc. So how do you link these different types and flavors of AI into this agentic world? Is it all... You command all through the LLM type brain, and every other AI becomes a tool in that sense? Or what is your take on this taxonomy of different AIs in agentic world?
Yeah, it's a good question. In fact, I don't know the answer, unfortunately. I'm still exploring. Sometimes I give just as tools, okay, and I control the process. I give the autonomy and the agentic tools. But I'm getting the intuition that I think the more freedom we give to the system, the better. So we'll give the capability. I think I have a slide. I have a slide that can answer this question, or can at least help answer this question. I have this slide like who is in control, how you control. There are several architectures you can, it's like the same answer to how to control your society, or to organize a society, because in the end you are talking about a society. And I'm starting to be in favor of having a more decentralized approach. So instead of having this initial, like you define the rules, you get the tools for each agent, what they can do, and you decide when to call each one of them. I think this more decentralized architecture, I think it will be better. So eventually self-organize. They self-organize in a way that they will decide between each other when to call the tools or when to evoke each other. But in case of biology, we need always to do this. You cannot rely purely on LLMs. You have to be always assessed to the simulation because they don't have capability to run the density functional theory models. It's very heavy computational models. They have to rely on external models. One thing, for instance, in my work I've done is with synthetic data. So I haven't done that experiment. I should have done one day because there is a way you can, instead of doing it, because this optimization takes many iterations, you can like thousands of iterations. And one thing I've done in one work is to, instead of running all the iterations, I run a few of them offline, and then I create a network to interpolate between all of these experiments, and the system can run much faster because it just relies on this. It's not accurate, 100% accurate, but it's good enough to get to the initial convergence point. So these kind of strategies, I believe, I haven't tested, but I believe and I would like to see that be emergent from the old system without you explicitly telling how to do it.
Maybe one last question. So it seems there was the first one. Yeah.
Okay, I asked the same question. I wanted to ask the first presenter is how price elastic the thing is. So if we raise the price 10 times, 5 times, where is the balance point where you are forced to kind of reject the way of doing agentic science?
Well, I think at this stage, I think agentic is much cheaper than humans, honestly. So, and the price is going to zero eventually. I'm a strong believer that the price of token will be visually zero.
But let's look at another way. So how much I can raise the price until you are still willing to pay?
Well,
let's ask in such way. So is it like 10 times or 3 times or 2 times?
My bottom line, if it's cheaper than my time, I will use it. So I use my time to do other things. So as long as I don't pay as much as my salary, I'm okay with doing that.
So I'm afraid we've run out of time. I just want, if I may, to mention one of the quotes that you didn't have time for, which was that the agent is useful not because it obeys, but because it is sometimes professionally annoying. Yeah. I think that's something for science really helpful, if someone can professionally annoy you and make you think differently. And that's something that agents can be good on. So thank you, Armando.
Okay, thank you. Thank you.
And now I'm happy to introduce our next speaker, Marilin Moor. She's a junior research fellow at the Institute of Computer Science, and she'll be talking about how hard can it be, our attempt to build an agentic system for microscopy image workflows. Please.
So, good evening, everyone. My name is Marilin, and it's such a great pleasure to be in front of all of you today. I will be presenting our attempt to build an agentic system for microscopy image workflows. It's going to be about our current system setup, why at first we thought it's simple, and why it's actually quite difficult. And by us, I am referring to the collaboration with Lukas Johans from the Leibniz Institute for Analytical Sciences. So I'm gonna skip the build-up and go straight to our current working solution. Here we can see a setup for the ideal user. So let's first talk about who the user might be. So the user is generally a biologist who needs help with some sort of image processing. Let's say there's an image open up right here. These are some fluorescent cells with nuclei and cytoplasm, and they need to get a histogram for the nuclei areas. They're also proficient enough to understand that they want to use a specific nuclei model for segmentation, so to extract the nuclei from the cells, and the image is open as is prompted. So our system, it thinks for a bit, but then after extracting the image metadata, understanding basically what is inside the image, as well as constructing a separate project for the user, the system will prompt a few more questions just to specify the problem itself and for the user to get as good results as possible. So the first question is regarding whether the user wants a script to be run, so everything is just run for them, it's automatic, or they want a UI-guided setup. So, for example, here, the track-made cell post plugin is needed to run, so the agentic system will basically provide you the steps where to click and when to click. Plus, there's other questions regarding the units they want to use. So for this case, the metadata didn't include any specific physical pixels, so it wants to be a bit more precise. Finally, the format of the histogram is confirmed to be a PNG. So of course, the user needs to interact with the agent somehow. So once they have entered their answer, the system thinks for a bit and executes the script. This is actually correct. I checked myself, so don't worry about that. You gotta trust me on this one. So the user outputs on the left a histogram, or deemed to be a histogram, and on the right we have a CSV table. Also, finally, as I mentioned, once the user inputs a prompt into a chat thread, a separate project folder will be set up for the researcher. So this includes all sorts of intermediate results, scripts that they can rerun down the road, or other files or images that have been created. So the idea here is to provide a solution for a biologist who can only use natural language and get closer to a result than based on the efforts that they had to do before. But what was happening before? So I must point out that this Agentic J is what we call our system, but that's great. So it's based on a really popular image processing platform for biologists called ImageJ or Fiji. I will use this interchangeably, just so you're aware. And the concept of Fiji is that you can use the UI to browse through different plugins or use different image processing methods. And you can also use a Groovy script for this. Now, where's the pain? Well, first off, when a biologist starts or tries to start using the plugin, they will probably end up on a documentation page. So first off, browsing through pages and pages of documentation to understand what the plugin is about. Then, once they understand how to use the plugin, they are aiming to get the plugin to work. This is often related to some headache to configuring a setup of some sort. So what they do, they Google the issue, and they end up on an image processing community forum, looking for answers, looking for help. And well, what they find out is that you gotta check out another documentation online. And this goes on and on. Of course, the biologists will end up getting the correct result, but this takes so much of their valuable time. So just to conclude, the pain points are, in this ImageJ context, are getting the plugins to work, using the plugins, and the fact that there are too many plugins. And this last part is mainly regarding to maintaining the platform or the plugins from the user's perspective. As plugins change versions, and as you all might know, conflicts occur, and some plugins are not working the same way as before, and et cetera, et cetera. So this is quite a heavy task, and we wanted to help them. Well, them, I mean biobiologists. And around that time, a bag of agentic number crunching systems were handed to us, basically. It was advertised, people were talking about it, and we thought, let's go for it. How hard can it be? Let's try to use let's try to create an agentic system for these tasks, and let's see what happens. So this is what we started off. By tracing through different blogs and people's experiences, we started off with setting up just one supervisor agent who's deemed to be a Fiji expert. Then everyone were roaming about RAG, so we also wanted to have RAG and have it connect to a knowledge database. Of course, it uses some tools to execute some scripts, and the medium for our case is not a Google document or a Google slide or whatever. It's a Fiji image processing platform. And of course, we need some input. So this is where the biologist comes in, who just interacts with the chat interface. And finally, the supervisor needs to have some sort of access to a data folder, which it can read and write to. So let's say we run the same task with just this one agent. And looking at the input token usage, it's not really an issue, because a maximum input token for one single call, so one subtask of this full task of finding the nuclear area, is around 25,000 tokens, which compared to the 200,000+ possible, it's not a big deal. But what really happened was the supervisor first seemed to skip any plugin-related information it was provided. So we wanted it to use a TrackMate cell pose. It opted for another plugin or a completely different workflow. So not taking into account any user input. Or a worst case, subjectively worst case scenario is that it got stuck with writing the Groovy script. So either it messes up with the file paths or correct function calls, etc., etc. So this is why we opted for splitting the task of one agent and dividing it into multiple agents, thereby directing the attention mechanism and forcing the agent to a context where it can consult with the specific info only. And this sort of aligns with research. There's a phenomenon called lost in the middle, which essentially is about long context models that show, or that when you're having a context long enough, they will only pay attention to the very beginning of the context and the very end of the context, but completely lose the middle part. So this is something that induced our efforts towards a multiple agent system. So let's cover those sub-agents. The first sub-agents we developed was a coder and debugger, which essentially are what they do. They write and debug Groovy code. But for that, Groovy code is quite specific, and the agent's internal knowledge is often not detailed or specific enough for this code. So we gave it a separate knowledge base for code recipes, templates, and also code errors. So it's sort of developing a collection of code errors that when some code fails, then in the next round, ideally, it will not stumble upon the same issue. Then another agent we used was the stats and plotting agent that uses Python mainly for statistical analysis and publication-ready plots. And it activates when prompted explicitly with plot, because recall the same first task I showed you, there was no beautiful plot there yet. But why would we need something like this? I did mention that the first task was supposed to give a histogram, but most of us know that this is essentially a line plot, and we wanted to provide the user something that they could already put into their publication without them having to move the data outside of the image.js system and do their perfect plotting somewhere else. So this is why we created this sub-agent, and here is a comparison. So on the right, to me, this looks more descriptive, visually pleasing, but also it gives some good statistical overview of what is the distribution about. Then another sub-agent we provided to the system is a quality assurance agent. It's mostly meant for reading the project setup. So it's essentially just going through the files that it has created, the inputs, any metadata it has created. And this project setup is verified against some publication standards. So for example, whether the environment metadata, for example, the library versions or these sort of things are specified, or whether in image processing, what were the pre-processing steps and specifics like that. But as this is quite expensive, the user doesn't have to run it all the time. And finally, as ImageJ is quite plugin-centric, we also added a plugin manager that does all the tasks related to plugins, checking, recommending plugins, so on. What I really like about this sub-agent is a tool that I created myself that checks for plugin user interfaces. What I mean by this is that, for example, here on the right, we have a plugin window. It has some parameters, some tick boxes, and so on. So if a user that's just starting to use the plugin doesn't know what it's about, then when it prompts the chat interface to ask about this window that's open and help give advice on what parameters to choose, then this is what it does. It essentially finds the plugin window, takes a screenshot of it, and bear in mind this is the only time an image is sent to an LLM provider. We're not using any input images because of sensitive data protection. We're not providing them into the LLM. So, but after the screenshot, the text is being, or the image is being transcribed to text, and the text is also being basically fused with knowledge about this plugin in general. So what it outputs the key parameter and what to look out for when you're changing the parameter value. So this is our system. This is how we've set it up. Something to note, maybe you noticed I had different flavors of models in the sub-agent chapters. And currently, we're just using API entry points via OpenRouter or OpenAI to support these because we didn't want a high entry barrier for the end user, as well as some unknown costs that might occur. But there's two other things that I haven't talked about yet. And one of them is the skills section. And when I'm talking about skills, I'm mostly here meaning how we are helping the sub-agents to have access to plugin documentation. So first off, the ImageJ platform itself provides 600 plus plugins. Obviously, there's no way to first make sure that all of these plugins are actually functional, and secondly, ensure that the skills files that are actually created based on these plugins are of high quality enough. So we took it down, we curated it to a 20 plus plugin set based on popularity, based on usage in papers and ImageJ site tracking stats. And the skills were generated based on the official plugin documentation links that we gathered and a prompt template. Of course, we needed to somehow test these. We tried automatic testing, but we ran into a problem. So one of the issues that happens in automatic testing is that if you do not define the test conditions in detail enough, and the test conditions should also reflect the real world, then it's really difficult to get valid automatic tests. So you might converge to really a high amount of successful tests, but it's not really telling or reflecting what the real world, what's happening in the real world. So we opted to also put the skills to the test using real examples from the same image community forum, as well as from data from biologists. And one of the really interesting fixes we got done, fortunately, was the following. So using the same task that I have talked about, if we were to want to run this and we use the nuclei model parameter, the whole task would take around $2 and 13 minutes. That's quite a bit, it's too long for us. So I looked inside the skills folder and files, and I found out that there's a really odd issue. The thing is that the parameter is not nuclei that is being passed. It's supposed to be nuclei torch _0. So if you fix this, it took 4 times less the time, 4 times less the money. So the main takeaway is that accuracy in skills matters. Like, you can generate them, it's all good, but you need actual use cases that sort of try to pinpoint the issues in your skills file. And finally, we're on to our last piece of the puzzle, that's the state ledger. So the main goal of the state ledger is to inject project context into sub-agents. Before this, we had the case that with every sub-agent call, you would need the full context, so the supervisor sent the entire conversation history. Now, this bloats obviously the attention mechanism, so we opted for a neater solution by using a state ledger and just the task description that the sub-agent needs to fulfill at that specific time. But what is a state ledger? Here I have provided you a snapshot of it. It's a JSON formatted basically file, another file, and it just includes very important parameters that I want to highlight. So one of the important parameters is the project root. So there, all of the scripts and images and intermediate files will be saved. And also the image metadata, that for whatever the amount of images you have per project, all of the files are provided, and also the metadata for the files. This alleviates like a lot of extra calls for extracting metadata for phase 1, phase 2, phase 3. So you only have to run it once, and that's it. You can come back to this again from the state ledger. Of course, there's a path for the relevant skills, for example, for the coder or debugger to look into. And most importantly, there's the pipeline plan. So this enables the sub-agent to first be on the same page, well, literally, and understand what task you're supposed to fulfill right now. So this is our system. It looks almost perfect. There's just one thing. We decided to containerize the whole process. This means that we containerize Fiji with its curated set of plugins, the agents, skills, and so on. Why did we do that? The main concern was security. I'm not going to go into details about, I'm not going to go into too many details, but I want to bring out one example, which in this case is rather relevant. So if we are having an automatic system that executes Groovy scripts, then there is a high likelihood, if the agent is malicious enough, there's a high likelihood of injecting or overwriting files. So from afar, these two script windows seem quite similar. But when you're looking closer, what happens on the right window is that the output CSV path is actually, there's a likelihood of it being rewritten to some other path, provided that the agent gives a path that it just decides to overwrite. So this can bring issues, obviously, because you can overwrite very critical conf files or SSH files or whatever you want. Then the other decision for containerization is from a user's perspective, and sort of touching the pain points I mentioned early on, is the ease of setup. So any operating system can use this Docker container with ease. The other context is from an ImageJ platform perspective, that the 25 plugins are pre-installed. The user does not have to deal with the setup themselves. And finally, a controlled environment does enable better control over the issues that may occur. So this is just to improve the debugging user issues. I can now claim that our system is final, but beware that this is just a snapshot of the current reality. Things may change. It's an ongoing development. And to conclude, so the difficulty always lies in the details. The scientists expect relevant reasoning and informative results. I must point out that I'm assuming that all professionals expect this, I would hope. Then there's the question of how to divide focus. And this really comes down to how many tasks you have and what is sort of the hierarchy of the system. High quality skills are not trivial. They're expensive and they take time of experts and other users. Containerization is an inconvenience for the developer, but highly needed for the end user. So that's just something that we praise every day when we are having issues with Docker container. And of course, there's still a lot to do in the to-do list, and you can track our efforts here. We have an open source repo out there. This being said, I thank you for listening, and I once again want to thank Lucas for this collaboration.
Please, time for questions. While you're preparing, you showed us really kind of amazing diagram of the whole system that you built, and it might look quite complicated. If you are new to Agentic AI and you want to now start using it, start to build something, so when did you start developing it? How long ago?
We started developing it in December.
December, yeah. So That's already like it's less or approximately half a year. But the tools have developed in the meanwhile a lot. So if you would now need to kind of from scratch build it again, what's your estimate like? How much development time would go in?
It's difficult to say. I feel like I am the bottleneck of the system. So, yeah.
I feel the same all the time.
So I don't know. I don't know about my capabilities. Maybe they've improved. Maybe they've regressed. I'm not sure.
But particularly to point out, I mean, coming up with some architecture like this is something that AI can also help a lot with. I mean, if I need to build an agentic system, I would, let AI help like come up with the overall architecture and a lot of the code also AI written. So it's possible even kind of to vibe code something to this like this together. But then, of course, there are going to be many problems.
Yeah, well, I must point out that during this period, we were already like this is the current snapshot. It's been edited, and yeah. So there's for example, skills wasn't a thing in December. So at first we put all the plugin documentation into the knowledge database. So, but this wasn't as successful, and skills came out. So we plopped it in, and now it's working better. So yeah, we're trying to be on track.
Okay. So I would like to ask a question. So you said that skills have to be specified very precisely. So the best specification of a skill is a program. Can you at some point replace agents with normal programs? Or is it not possible?
By normal coders, you mean?
Normal program. So you have some where there is no calls to the LLMs or no, just QA program.
Yeah, so we already currently kind of have, so I wouldn't say that our system is like, the code is only generated. We're already using code templates, code recipes. So this is already like a boilerplate, like 60% of it is already there for a normal coding program. But what I would like to point out is that if a user comes in with a plugin that's completely out of the normal boilerplate code or has some other demands or requests, then I'm not sure how a normal coding program would cover all of these. The dimensionality is quite vast, and I feel like this complex system would maybe help cover it to some extent, but we're having this hybrid approach currently too.
And last question.
Did you also explore the GraphRag databases?
Yeah, we did. GraphRag, great stuff. But the only issue is that the latency is quite slow. And developing and figuring out the graph structure and understanding if it's valid or not is also kind of can have issues. Yeah. All right.
Thank you so much. And I hope now to get the agenda here. Yes, so we are ready now for the networking, and make sure to come back because you will see talk by Sten Verjerko, and this is not going to be recorded. This one is so special that you'll see. And also the panel discussion, you will hear a lot more about how organizations should really act, not only the technical part. So see you at 25. We have a bit of a delay, so 18:25. So we've heard many different perspectives. We've heard about the technical side. We've heard about the also organizational side and a bit of personal usage. But this is something that Stenver already mentioned, but maybe I'm asking also from the others. So do you also have like 24/7 some agents doing stuff for you? So your answer is yes. So let's continue with Kristjan. And also, I mean, maybe to separate a bit like generic company stuff and your kind of maybe personal role in the company. So something that is really agents that are doing work for you directly.
I would say no at the moment.
So, and what's your replacement? Are you kind of more working with like tools that are just responding like a usual generative AI style?
No, I'm more like thinking.
Reasoning, yeah.
Yeah, I mean, it's also fine. Like, I mean, this agentic stuff is not in that sense that special either. Like, managers have always vibe coded in their life. They have never written code. They have said that this must happen, and then people are working. And it's the same now. So in that sense, vibe coding happened before for them as well, and not much have changed. Only maybe that instead of 10 people, you now need one who you tell the command to. So I think I prefer at the moment still this, that I will not be the person doing it already, because there is also this argument that if everyone does it, then maybe the value which will be more important, or where you will have a competitive edge, might be not doing it. And then maybe simplicity and style and uniqueness or creativity in or some other aspect is also valuable.
But for example, the kind of AI communication, as Stenver was showing, like giving commands to your AI agents through Slack, is that something
that's not 24/7. Of course, yeah, I have AI agents in Slack.
But they do shorter
so
jobs.
Yeah, we have special ones that analyze data, that can gather ones, special ones that analyze code. Yeah, of course, we have AI agents doing work for us, but I guess this is something different. There you are giving a small command, not that it's 24/7 running for you. And usually they also don't, I don't like when they generate stuff for me. They usually help to explain stuff or find stuff, and it has a difference as well.
Yeah, I have a startup myself, but we don't have much agents working there. I can tell from my scientific side. I think there's a discussion here we need to be a bit careful, because I start to think that humans are being the bottleneck in these organizations. So our cognitive capacity is really the bottleneck, because you cannot cope with this speed and this flux of information and this autonomy that the agents are having. So and it's becoming very hard to keep track of all these activities. So I see the moment where the agents start to behave in our behalf and sending emails and doing things in our behalf, and we start losing like this cognitive dissonance. Like, did I say that? Did I send that email? I mean, I don't remember anymore. So yeah, I mean, I don't know. Just yeah, I don't have an answer for that. Answer to your question, I definitely not have 24 hours running. Otherwise, I will have to shut down my brain. But it's yeah, it's really some relevant questions we need to think about.
From my perspective, I don't really have tasks that need to be run 24/7 at all times. I'm sort of having a different background, and partially also feel that I'm more used to this user-induced interaction, first of all, and second of all, if there was a task that I would need to want to get solved, I would still want to be part of it within the 24 hours, for example, already within the first 24 hours. So I whether it's based on the experience, the tasks I've had, I just don't currently see the need for this.
Mm-hmm. So I don't have 24/7 agents, but I'm thinking that this time might come relatively soon. And I think research being open-ended process, I think there is a lot to explore. That I mean, getting new research ideas is something that maybe is useful to give some exploration, as Armando was putting it, right?
Yeah, but at some point, I mean, I start having this doubt myself, so don't take me wrong. Just as he said, I mean, there's a point we stop connecting with the process. We feel like observers of this, so they are doing everything for us. And what are they doing? I mean, what am I role in this process? It's just you feel like an observer, not intervening on it. And it just this thing of control is just I mean, I don't know. It feels weird.
I guess one easy case would be reviewing new research coming out and connecting it to your different projects and different papers you're writing at the moment and so on. And I guess that would be relatively valuable.
I just add that you can never be an observer, you're a pilot.
Yes, that's the thing. But if these things go wrong, it's just, I
don't know. And modern pilots almost don't do anything anyway. They just sit there.
Just take off and land.
Yeah. They don't even do that, to be honest. They don't, I think.
Maybe Stenver commented or explained how his process is, and also that there are even on the same topic there are multiple agents, and overall pretty large set of agents that you're working with, like seemed like 20 plus at least or something of that sort. So I imagine you need to do quite a lot of context switching between them then. Is it that you now need to do more context switching than before? Is it something where you feel mentally it's kind of the cognitive load has substantially increased, or it's not an issue?
You definitely need to do faster context switching, which is like more in a single day. But you know, if anybody that has ever run a project or run a company or run like anything that's actually complicated knows that this is just, you know, basic manager stuff, basically, like Kristjan said. You know, if you're a CEO, you anyway do context switching all the day. Now just everybody else also does context switching, right? So it sort of changes. Everybody becomes like more managerial, essentially, and like when we're hiring, we're looking for people that can like specialize in an area of that managerial competence, right? So if we need like a developer, they still need to be an excellent developer, but now they need to be excellent managers of AI agents as well. And managing AI agents is frankly a lot simpler than managing humans. So, you know, it's a lot easier skill to learn. Basically, it doesn't take years. And so yeah, answer is yes.
So yeah, context switching is okay. It is a lot of kind of mental load, but you're used to it as a kind of CEO. You need to do it anyways.
Yeah, and you know, when I watch how all of the people we have working with us work, it's, you know, they also do the context switching. You sort of get you need to do less like total context switching, right? You don't anymore have to usually jump between topics completely, but they still do it like in their area. You know, our developers use work trees and work on 3 or 4 projects at the same time. So when they develop code, so it's normal and it's okay basically.
But now more broadly, I mean, we've talked about your own use cases and how much you use AI agents that are running continuously, but what about the rest of your organization? Is Stenver, I assume your company, everyone is full on. How is it with your company?
I think like 80% use it every week. .code.
Mm-hmm. But
I'm owning an answer to Jaak. Never own anything to Jaak. So for us, it's by quarters, and it has been increasing more than 2x every quarter for last 5 quarters, I think. So Q2 25, it was 3,000, Q3 10,000, Q4 last year 22,000, Q1 50,000, and most likely it's going to be 100,000 this quarter that is ending soon.
So it's AI usage cost?
Usage cost by employees, not by software and customers, only by employees.
How many people?
Like it hasn't increased that much, but at 160.
You talk about euros. These numbers are...
I don't know, about
euros.
the same.
Euros or dollars?
Yeah, Stenver is definitely using more. And another thing we discussed, I forgot to say this, but if everyone becomes instantly faster and produces a lot more, the misalignment is not happening when you have less than 20 people in the company. Then everyone knows everything and they kind of are more in sync, and then in total what they produce is also less because they cannot review that much either, and so on. And also, it doesn't seem to be happening when you have more than 50,000 people in the company, because then the processes are so rigid that you are unable to anyway change or push features into the code base, because it's going to be so many reviews and the salespeople know it half a year ahead, because there are so many processes there that make it such, because they needed the coordination so much already. So it seems to be a problem, maybe not a problem, but a feature of like if you have like 20 to 50,000 people in your company, maybe.
For this alignment issue, we haven't proven it yet because we're 12 people and soon will be 14. But our way we're trying to avoid this and sort of create a new organizational paradigm is similar to like Silva is doing. So we have like this company brain. I mentioned that all the tools are hooked into the core system, but so is company brain. So, after the sales calls, every week the agents are taking like the best calls and everything and improving the fundamental materials. And any employee, when they have a question about company's business or compliance, we're in compliance business, so we have a lot of questions there. Then they can just ask AI, and AI basically looks up in our internal database. And I don't know if this experiment works, we'll see. But the hope is this can basically flatten the knowledge graph, because your AI is your knowledge graph.
You're insulting me. Of course, we have it as well.
So in terms of in your organization using AI, agentic AI as well. So from the university side, I'm sure there is a lot of diversity, right? I mean, there are people who don't use at all. You are among those who use a lot, and do you communicate with other colleagues who work similarly on agentic systems and share experience? Any particular interesting insights you've heard from colleagues?
Yeah, from my side, all of this is new. I have the feeling that the more intelligent people are, like in academia, they feel a bit more. I don't know, but I have this intuition that they more skeptic about AI because they feel afraid that I'm the most intelligent person in the room. I know quite a few that work quite intensively with AI, but I have the feeling that that still this. I don't know if it's fear or skepticism. I don't know what it is exactly. I feel that in academia is still we're becoming a bit laggards in some sense. I'm very open to I'm very experimental to all of these new tools, OpenClaw, Agentic AI, and as I said in the talk, it's been very fruitful. Also, I have to say, just a comment on that, like when publishing or trying to publish in some journals, I find very frustrating. Sometimes they say, "Oh, this was written by AI," and they don't provide any evidence it was written or not written. some sections they may be written with AI, but overall I think it's very frustrating for the author that he put a lot of effort in that particular work, just without having any right to respond and to say it was not right. So it's very frustrating on the side. And at the end of the day, the point is, who cares? If it's a good idea, if it's a good result, if it's helping to progress science, who cares? I mean, I can put in the paper title, ChatGPT, OpenAI, Armando, Vieira, whatever. But what matters is the idea, if something is really helping science. But I think we need to overcome this stigma, really because I don't think it's doing any good. Yeah, just share a bit of my frustration on that side. But in terms of collaboration, yeah, I mean, I had, in fact, one of these collaborators I am working at the moment is in these genetic rhetoric networks. I found him through perplexity to know people working in this field. So yeah.
Yeah, so I agree that in terms of research outputs, is it grant proposals, research papers, it's quality really that matters. Yeah. And of course, there must not be any plagiarism and everything needs to be attributed properly, referenced and so on. Yeah. But as long as everything is done correctly, ethically, then eventually quality matters and AI can be used. And in the AI field, AI research, it is now, I think, commonly agreed that this is the process, that AI usage is a normal thing in research.
So I have a feeling that in this room there's a really high local density of agentic AI users, and we're sort of living, or we're in this bubble. We're surrounded by the same set of people. We're influenced by sort of a similar set of agentic influencers. But if we look outside, then the picture is quite different. So I've had some experience in some chats with biologists, and currently the state is that the web chat, so people browsing the AI chat, has become more common, at least for biologists. But getting to agentic AI and actually executing scripts in some sense requires still some background knowledge. Like before AI, all of us still knew how to code who are using agentic AI. And that's actually what me and my colleague Priit went to do in Prague the last 2 days. We went to teach basics in Python. Seems kind of weird in this era, but the truth is there's really no point in getting or using an agentic AI when you're not understanding the output at all. So we're slowly starting to make efforts towards biologists being more resourceful in using their own skills. So I'm not sure that the agentic AI is helping them or would help them right now.
Mm-hmm. Yeah, I agree that having a knowledge about programming is continuously useful. But of course, I think there are still also roles where it's not necessary. And you can vibe code things, and you can have kind of checks, guardrails to ensure that eventually everything that is produced, that code is working correctly, testing and I don't know. Yeah, but I think it's possible to have roles where it is indeed not necessary to know programming anymore. Everyone agrees or not?
I think I give an example of my students. So I allow my students to use full-scale AI. I don't really care, whatever they come along. Some of them don't really, they are not very good coders. Some of them, they barely know how to code. But what I ask them is they need to explain what they did, they need to understand what they did, and they need to at least show some evidence that they they understand the output and what could be the reasons for some mismatches or some insights that are not okay. And another thing I put very strong stress is, I think overall that's a message I'd like to convey for all the professors. I think we should, these technical skills, I agree, are important, okay? And the AI can help them acquire these skills, but they're becoming less and less relevant, I think. In the organizations, it's also important to understand the business, understand the communication side, how to communicate our results, how to make actions based on your insights, not just show nice PowerPoints or nice models, but how that will impact the business. And then they have no clue about that. And I put strong emphasis on that. And it's super important that they acquire these extra skills, because the technical, like producing models and nice visualizations, is becoming a commodity. It's relatively easy to do with AI, but the extra step, I think, is a bit harder. But I agree. I mean, coding is still important. We need to understand, at least to be able to read what they produce and see where is things to be improved. Is absolutely essential.
Yes. Any questions from the audience? Yes, there is. But while the microphone is going there, but I must say that the last kind of tools that I've written for myself to help in my work, I haven't looked at the code at all. Like, it's fully vibe coded, and they are genuinely useful tools for me, and it's okay.
Okay, so thank you. AI is a very good multiplier and very good at introducing all sorts of covered agendas into everything it generates. But in the wake of AI adoption, a new industry has spawned, which seems to be much more advantageous and more interesting. So my question to the panel members is, how long do you think it will be until someone corrupts the models that you're using and uses them to tank your company or blow up your research?
We're already doing it. So once our audited annual report from Soldera OÜ comes out, if you're very bored, just go read it. You'll have a lot of fun. AI poisoning and authority farming is a huge topic. So yeah.
So you've been hit already?
No, we're
you are hitting.
Yes.
Oh, okay.
Yes.
Okay. I see.
Whatever it takes to win.
Okay,
yes.
So you basically, what you're saying is that you can kind of, with your actions, you can steer other people's agents towards
100%.
Your preferences.
It's a huge industry and huge topic.
Similarly as search and it has been before.
Exactly, and it has already yielded us. So I mentioned before in the presentation how our site authority has raised like extremely high in the half year. We also have noticed our model authority have raised in parallel, and this has made us think a lot like how can we further raise the entire AI to think like we do. And whenever somebody asks anything about our industrial context, that we would always be the top answer, and our articles will be referenced and our answers will be referenced. It's absolute information war out there.
There is a good book called When a Machine Becomes Your Customer, which kind of sums up this, that it seems more and more likely, or it seems to be happening, basically. But I think the question was not that. I think the question was that we are using some LLM that is doing harm for our company internally, was the question. And I think this is a lot less likely than it seems, because there is no incentive for Anthropic or OpenAI or Google or anyone to do it, because they will lose customers in the future because of that, but they don't gain anything, Pactum going bankrupt. So that doesn't make sense for me.
No, there have still been supply chain attacks where people have used one site, LLM agents. Those agents were corrupted and
Can you please repeat the question?
No, there have been issues with supply chain attacks where a company hosts a local LLM model for some reason, and then that model is corrupted in the cloud. So when the company downloads it, then that model behaves maliciously.
Sure, but this is similar to any other kind of downloading a library and having an attack in there. I don't think it's that much LLM specific. You can always have malware in any library or attack in there, which I guess sometimes now happens more often because agents are downloading different libraries and installing them in your machine, and that attack vector has increased. But yes, this can happen, but I think it's a bit different.
Yeah, I just wanted to add we're not doing that. So we're doing basic AIO.
Yeah.
So a question here, but while the microphone is going, so maybe thinking about Estonia and Estonian companies, universities, organizations, do you see kind of what's your positive path forward to kind of where do you think we should be moving, and is it rapid agentic AI uptake that we should do as rapid as possible, or what do you think should be the way forward?
In this respect, I think you should look at China, honestly, in terms of country-wise. Don't get me wrong, the good things, not the bad things. Because China, they have a very interesting. Well, I think you're judging too fast China. China has a lot of good examples in terms of AI adoption and AI education. I think we have done some good efforts here in Estonia compared to other countries, but I think I will put as country level, I think education of not just in the university, but country-wise to what these tools, any population, and also the risks and the benefits of using AI. I think I have two daughters. They study in Portugal, but there's zero education about that. They don't know anything about AI. I have to teach them myself. I think it's not good. And also in terms of supporting that, I think all Europe, Estonia, I don't know the Estonian case, but all over Europe, I think we are a bit too afraid and too don't risk avoidant at the moment. I think we should be ask for forgiveness instead of permission more. Act more a little by startup, and because it's about failing, about trying, about deploying, about giving the conditions for really the tools to flourish fully, and with some guardrails, of course. But I think we really should be more adventurous and more audacious in this endeavor. I think all over Europe is not. I don't see good signs, honestly. That's my opinion, but yeah, I think education is something you can do quite quickly and effective. Probably put a bit more emphasis on that.
Similar question was asked when LLMs came out, and I was very against it for Estonia to be big on it because it's such a capital-intensive thing and it's extremely difficult to compete with the best of the best in the world. And it felt impossible for Estonia to have any competition there at all. But with agents, I think it's very different. All of these things are extremely simple, lightweight programs that are just utilizing LLMs. You can read the full source code of OpenClaw, and it's not that magical. And also you can provide MCP servers for agents, which would be very useful for them. Even university can tap into this resource by providing an MCP server for agents if someone wants to read about what you can study here and so on. So I think we should definitely utilize all of this infrastructure, and it's meant for small countries and small people and small teams more than they are actually for large. So I think it is the best place to go all in.
So you more answered on the technical side, like mentioning MCP and so on, but it is also possible to be agentic AI really only from the user's perspective, like where you don't know anything about that and you just kind of launch processes like, I mean, you could, for example, take OpenClaw. You can basically run OpenClaw without any technical knowledge, I think.
I mean, yes, people can use whatever they want and they can use what's useful for them. But yes, I meant more what should the university do, what we should building as companies, what can the government do, and so on.
Okay. Did you want to?
No, I think it's covered.
Okay, so we are in a university building, so I have a teaching/learning related question. So Stenver also mentioned the kind of people you don't like to hire and like to hire. And I think there was a panel a month ago or something, students organized it about AI. And they were really worried that they don't understand how much they should use AI, how much they should force themselves to think on what kind of topic and so on and so forth. So what to think and try to do on their own, but also they are expected to use AI when they go and search for a job. So basically, I have my own opinion on that, but we have this excellent opportunity of having you guys here. So this question is mostly maybe to Stenver and Kristjan in that way, that you can maybe answer also not only looking from the point of view of your own company, but in general, what you think about this. What would you say to a student trying to study computer science?
And so I think there are like two different simple ways how to distinguish the usage of AI. One is to use AI to become better versus to use AI to not understand and become worse by letting it do stuff. And I mean, even this Stenver's example of board materials, I mean, in order for you to validate whether the materials are good, most likely you need to first have a discussion with AI to become good in understanding what are good board materials. And this use of AI seems absolutely brilliant of having a personal tutor-like thing and getting into very high level in very quickly in any field. And if you're unable to get extremely good in absolutely any field, in every task, then this seems like an extreme weakness indeed in this environment. But I don't think that this has extreme competitive advantage, that you are good in prompting so that the good outcome comes out. Because this is easy, then the output is not, then everyone can do it, and this doesn't have the competitive advantage that much. Maybe in advanced cases a bit, but so you can, there is a difference there whether you use it as someone is doing job for you or you're using it to enhance yourself in everything.
Well said. And if you are using it smartly, then I think there's only one answer: agent maxing. I hope my presentation made that clear. Like, don't believe the skeptics. Like I said, they usually are just, pulling you back. So in my experience, skeptics are actually rarely right in the long term. In the short term, yes, but failing is fine. It's part of the learning process. And then just agent max and focus on learning with it.
Can I have a short follow-up or not?
Yes.
Okay. So just about studying, let's say, computer science, and should they just not study and go and try to pick a problem and start working on it and learn by doing, or they should still kind of go to university and study in a systematic way the kind of skills that we teach in computer science?
I'm sure Kristjan has an excellent answer being a scientist, but I'll just add from my end that you often don't know what you don't know. And I think university is an excellent foundation layer, as it always has been.
I think you should just ask agents what I don't know and they tell you so. And of course, you can ask agents of what are they studying there in the University of Tartu in Computer Science Institute, and it will look it up and it will teach it to you. Not impossible, not worse, but I think studying it has many other kind of benefits. Like some people are even studying such that they don't go to the lectures and stuff, but it still gives you structure. I still recommend going to the university. First of all, if you get a degree, it shows that you can accomplish something. And second of all, I think it's more about discussions and people and relationships and everything around it, and also about like diverting your motivation towards one thing, because you can get also lost very easily of being able to study everything everywhere. Like, why not? You can also do a side business while studying if you're worried about not doing a business.
Just a small comment on that. I think the role of universities definitely is changing, and they need to find I don't have a very clear opinion on that. I have mixed feelings about all of this. Should just offload all the cognitive tasks to AI and just prompting, so in the end everybody will be just prompting engineer. Without really understanding what is behind. But the reality is that really we need to incorporate is in the past, the knowledge was scarce, or the scarcity. Knowledge is not scarcity anymore. Okay, knowledge now is abundant. Abundant is accessible. Before internet was also abundant, but was not accessible. Now it's accessible in the way you want it. This was like a privilege of universities that is gone. Okay, we don't have this privilege anymore. So I used to say to my students, if you want to really know deep about some topic, ask ChatGPT, because I'm sure it will know more than me about any topic at the level I'm teaching. I have no doubts about that, and to be much more patient than I am. That's the level we are at the moment. So what are you going to teach to the new generation for the new jobs requirement? It's really an open question. I think we discussed here this neurodivergency. I think it's more important than giving the answers is getting the questions right, okay? Picasso used to say, he was very impressed by computers, Pablo Picasso. He said in a very common statement, say, they are completely useless. They just give answers. And I am a bit with him in the sense that more important than the answers is the questions, or what the questions you are willing to put to the system. And how you're going to teach students for that. Just for me, it's topics we need to be discussed. I don't have the answers for that myself.
Do you want to comment on this one, or should I ask the last question?
Go ahead.
We've heard many great things. We've also heard about risks, but kind of looking into the future. And maybe this question is not about agentic AI so specifically. AI is being in very rapid changes all the time now, but what is your kind of optimistic view towards the future? There are risks. We cannot cover all risks today, unfortunately, but your optimistic view, what would be that?
I think for optimism, we should turn to Stenvar first.
I hope I already answered it. It's more ambition than ever, and higher quality and higher goals than ever, and more specialists, highly trained specialists than ever. So I fundamentally believe that.
I can give an optimistic message. I think in terms of science, I am truly optimistic that these models will help solve one of the many big questions, like superconductivity at room temperature, cure for many types of cancers. I'm truly optimistic that we're going to achieve that. I collaborate with a company with drug discovery, and that is just, they have a drug at stage 3 of trials for treating a very severe malfunction of the lungs. I think in the next couple of years we have this drug approval, and many other will come after. For the ones who don't know, putting a drug to the market, it's very expensive, because at the moment like $4 billion for each drug. I think that has to become very, very much lower. And yeah, I'm super optimistic that we're going to have great progress.
Actually, wanted to add this one thing. I suddenly remembered that yesterday I was out having a beer with my colleagues. We had strategy days, and we literally had a similar discussion. And my colleague Al put it very well over there, that every technological revolution what we had has, over the long run brought us to next level of utopia, basically. The life has never been as good as it has been in history. Compared to Roman emperors, we live better, frankly, all of us. So it's, when tractors came out, there were literally riots on the street. People were mad. They're taking our jobs. But in the end, the society got richer, wealthier, everybody's lifestyles improved. All the like fundamental metrics of society have gone to the right direction, basically. AI is going to do the same, basically. It's my belief.
We've run out of optimism.
We're out of time. Okay. I actually, when we were talking about optimism, then I would like to drop a bombshell and well, I don't have a full understanding of the energy consumption that the agents are currently using in the system. And my optimistic view would be that we would have models and agentic systems that are less resourceful, but still useful, and useful in a meaningful way, not just to create slop and so on. So that's my optimistic view.
And continuing on the same aspect of enhancing ourselves, then I'm optimistic that in my lifetime I might be able to answer and experience things that I thought are impossible to answer, and to travel to other stars, understand what's consciousness, become immortal if I want. Thank you.
Yes, it's great to end with this optimistic note. Thank you very much for everyone for coming. Great thanks to our speakers. And I would also very much like to thank the team that has helped to make this event succeed. The team from the industrial collaborations, Ruth, also the IT comp team for all the recordings, and thanks so much. Looking forward to see you in the next data science seminars. Give us feedback about what you want to hear more about, and we'll see you in autumn. Thank you.